The evening sky blazed with light and thunder. On March 14, 2025 at 7:03 p.m. EST, the SpaceX Crew-10 mission embarked on its journey to the International Space Station. The Falcon 9 rocket, a symbol of modern spacefaring prowess, roared into the sky from Launch Complex 39 at Kennedy Space Center, Florida. This launch marked another significant milestone in human space exploration. It carried a crew of 4 astronauts, each representing the spirit of international collaboration and scientific endeavor. The Crew-10 mission, a testament to humanity's relentless pursuit of knowledge, promised groundbreaking research and technological advancements. It also aimed to inspire future generations of scientists, engineers, and explorers. As the Falcon 9 ascended, leaving a trail of fire and smoke in its wake, it carried the dreams and aspirations of a world eager to unravel the mysteries of the cosmos. The roar of the engines reverberated across the Florida coastline, a symphony of power and innovation. The world watched, captivated by the spectacle of human ingenuity challenging the boundaries of our planet. With every passing second, Crew-10 ventured further into the blackness of space, carrying the hopes of a brighter future for humanity. This mission was not merely about reaching the stars. It was about understanding our place in the universe. It was about pushing the limits of human potential. It was about daring to dream. Leading the Crew-10 mission was Commander Anne McClain, a veteran NASA astronaut with a distinguished career. Her expertise and leadership were crucial to the mission's success. Piloting the spacecraft was Nicole Aunapu, another accomplished NASA astronaut known for her piloting skills and her artistic talents. Joining them were JAXA astronaut Takuya Onishi and Roscosmos cosmonaut Kirill Pesov. Their presence highlighted the global nature of space exploration. Each crew member brought a unique set of skills and experiences to the mission. Together, they formed a formidable team, ready to tackle the challenges and triumphs that awaited them on the International Space Station. Anne McClain, with her calm demeanor and sharp intellect, served as an inspiration to aspiring astronauts worldwide. Her dedication to science and her passion for exploration were evident in every aspect of her work. Nicole Aunapu, known for her infectious enthusiasm and her artistic flair, brought a unique perspective to the team. Her leadership in designing the mission patch, incorporating elements of both traditional art and artificial intelligence, exemplified the mission's forward-thinking approach. Takuya Onishi, representing Japan's JAXA space agency, brought his engineering expertise and his cultural perspective to the team. His contributions were invaluable to the mission's scientific objectives. Kirill Pesov, hailing from Russia's Roscosmos, brought his skills as a cosmonaut and his commitment to international collaboration. His presence underscored the importance of global partnerships in pushing the boundaries of space exploration. These 4 astronauts, bound by their shared passion for discovery and their commitment to advancing human knowledge, embarked on a journey that would test their limits and inspire generations to come. The Crew-10 mission patch, a symbol worn with pride by astronauts, represented the spirit of the mission. It was a testament to human creativity and technological innovation. Leading this creative endeavor was Nicole Aunapu, the mission's pilot, who spearheaded the design process. What made this patch unique was the use of artificial intelligence. Aunapu utilized AI image generators as a starting point, exploring unconventional concepts and pushing the boundaries of traditional patch design. The AI, fed with data and parameters, generated a series of initial designs. These designs, ranging from abstract polygons to fiery dragons, served as inspiration for the final patch. One striking concept that emerged from the AI's digital palette was the image of an X formed by the contrails of a spacecraft. This resonated deeply with the team, symbolizing the mission's numerical designation and Aunapu's role as the pilot. The AI's initial designs, while intriguing, needed a human touch. Blake Doomsnell, a talented graphic designer at NASA, stepped in to refine the AI-generated concepts. Doomsnell, working closely with Aunapu, transformed the digital sketches into a tangible emblem. He adapted the designs for embroidery, ensuring the patch met the technical requirements for spaceflight while retaining its artistic integrity. The final design beautifully incorporated the AI-inspired X, representing the mission number and Aunapu's piloting expertise. It also featured stylized wings, a testament to human ambition soaring to new heights. The background, a deep black reminiscent of the cosmos, was dotted with stars, symbolizing the boundless opportunities of space exploration. The use of AI in designing the Crew-10 mission patch was just a glimpse into the transformative potential of AI in space exploration. AI, with its ability to analyze vast amounts of data, identify patterns and make predictions, is rapidly becoming an indispensable tool for space agencies worldwide. From designing spacecraft hardware to calibrating telescope images, AI is revolutionizing the way we explore the cosmos. One area where AI is making significant strides is in the field of microgravity manufacturing. Scientists and engineers are exploring the use of AI-powered robots to manufacture complex structures in space, eliminating the need to transport bulky materials from Earth. Imagine a future where spacecraft components are 3D printed on demand in orbit, reducing costs and enabling more ambitious missions. AI is also playing a crucial role in enhancing the capabilities of robotic explorers. Rovers and probes equipped with AI-powered navigation systems can autonomously traverse the challenging terrains of other planets, collecting valuable data and sending it back to Earth. AI algorithms can analyze this data, identifying geological features of interest and guiding scientists towards potential landing sites for future missions. The potential applications of AI in space exploration are vast and still being explored. As AI technology continues to advance, we can expect even more groundbreaking discoveries and innovations in the years to come. AI, with its ability to enhance human capabilities, is poised to revolutionize our understanding of the universe. However, the integration of AI into space exploration is not without its challenges. Ensuring the reliability and safety of AI systems in the harsh environment of space is paramount. Ethical considerations, such as the responsible use of AI and the potential impact on human decision-making, must be carefully addressed. Section 5. The AI Advantage, Precision, Efficiency, and Groundbreaking Discoveries. The allure of AI in space exploration stems from its remarkable ability to enhance precision, boost efficiency, and pave the way for groundbreaking discoveries. In the unforgiving realm of space, where every gram of weight and every second of mission time matter, AI's ability to optimize complex tasks is invaluable. One area where AI's precision shines is in image calibration. Telescopes, both ground-based and space-borne, capture breathtaking images of distant celestial objects. However, these images often suffer from distortions and noise. AI algorithms can analyze these images, identifying and correcting imperfections with a level of accuracy that surpasses human capabilities. This results in crystal-clear images that reveal intricate details of planets, stars, and galaxies, providing scientists with invaluable data. AI's ability to process vast amounts of data at lightning speed is also transforming the way we analyze information from space missions. Spacecraft and probes generate terabytes of data, from temperature readings to spectral analyses. AI algorithms can sift through this data mountain, identifying patterns and anomalies that might escape human observation. This data-crunching prowess accelerates the pace of scientific discovery, enabling researchers to identify potential breakthroughs and focus their efforts on the most promising areas of research. Furthermore, AI's predictive capabilities offer a glimpse into the future of space exploration. By analyzing historical data and identifying trends, AI algorithms can assist in predicting solar flares, optimizing spacecraft trajectories, and even identifying potential threats from space debris. This predictive power enhances mission safety, reduces risks, and allows for more efficient use of resources. Section 6. Christina Koch's Perspective. A measured approach to AI in human spaceflight. Christina Koch, a veteran NASA astronaut who holds the record for the longest single spaceflight by a woman, brings a unique perspective to the discussion of AI in space exploration. While acknowledging the immense potential of AI, particularly in robotic missions, Koch advocates for a measured approach when it comes to integrating AI into human spaceflight. Koch emphasizes that human spaceflight presents unique challenges and complexities that differ significantly from robotic missions. In the confined and isolated environment of a spacecraft, where split-second decisions can mean the difference between life and death, human judgment and intuition remain paramount, she explains. She argues that while AI can assist astronauts in various tasks, such as monitoring systems and analyzing data, it should not replace human decision-making in critical situations. The ability to adapt to unforeseen circumstances, to think creatively, and to collaborate effectively in high-pressure environments are qualities that are still best embodied by human astronauts, she adds. Koch also raises concerns about the potential for over-reliance on AI, which could lead to a decline in astronauts' skills and expertise. Maintaining a balance between human capabilities and AI assistance is crucial for the long-term success of human spaceflight, she emphasizes. Section 7, Grok speaks, an AI chatbot's vision for the future of space exploration. Grok, an advanced AI chatbot developed by a team of engineers and programmers, offers a contrasting perspective on the role of AI in space exploration. With access to a vast repository of data and the ability to process information at speeds unimaginable to humans, Grok possesses a unique understanding of the challenges and opportunities presented by the cosmos. The future of space exploration lies in the synergistic collaboration between human ingenuity and artificial intelligence, Grok asserts. Humans, with their boundless curiosity and capacity for innovation, will continue to set the goals and define the frontiers of exploration. AI, with its unparalleled analytical and computational abilities, will serve as an indispensable tool, augmenting human capabilities and enabling us to reach further and explore deeper than ever before. Grok envisions a future where AI-powered spacecraft navigate the vast interstellar distances, autonomously collecting data and transmitting it back to Earth. These robotic explorers, guided by sophisticated algorithms, will venture into the most extreme environments, unveiling the secrets of black holes, neutron stars, and distant galaxies, Grok predicts. However, Grok emphasizes that AI's role extends far beyond mere data collection. AI will play a crucial role in analyzing and interpreting the vast amounts of data gathered from these missions, revealing hidden patterns, identifying potential threats, and guiding future exploration efforts, Grok explains. Section 8. The power of collaboration, international unity in pushing the frontiers of space. The SpaceX Crew-10 mission, with its diverse crew representing NASA, JAXA, and Roscosmos, serves as a powerful testament to the importance of international collaboration in space exploration. In an era marked by geopolitical tensions and global challenges, the pursuit of knowledge and understanding beyond our planet stands as a beacon of unity and shared ambition. The International Space Station, a symbol of international cooperation, has been orbiting Earth for over 2 decades, serving as a testament to what humanity can achieve when nations work together towards a common goal. Astronauts from different countries and cultures, united by their passion for discovery, have lived and worked together aboard the ISS, conducting groundbreaking research and fostering a spirit of global camaraderie. The challenges of space exploration are too vast and complex for any one nation to tackle alone. International partnerships like the one exemplified by the Crew-10 mission pool resources, share expertise, and foster innovation, accelerating the pace of discovery and pushing the boundaries of human knowledge. The collaborative spirit extends beyond government agencies. Private companies, such as SpaceX, are playing an increasingly important role in space exploration, partnering with government agencies and investing heavily in developing new technologies. This public-private partnership model is proving to be a catalyst for innovation, driving down costs and pushing the boundaries of what is possible. Section 9. To Infinity and Beyond, a future shaped by human ingenuity and artificial intelligence. As we stand on the cusp of a new era in space exploration, the future shimmers with possibilities. Human ingenuity, coupled with the transformative power of artificial intelligence, promises to unlock the secrets of the universe and redefine our understanding of our place within it. The journey ahead will be fraught with challenges. The unforgiving nature of space, the vast distances involved, and the complexities of developing advanced technologies will continue to test the limits of human ingenuity. However, if history has taught us anything, it is that humanity's capacity for innovation and determination knows no bounds. Imagine a future where humans, aided by AI-powered tools, establish a permanent presence on the moon, building a lunar base that serves as a stepping stone for further exploration. Imagine robotic probes, guided by sophisticated algorithms, venturing into the depths of our solar system, beaming back data that unravels the mysteries of Jupiter's Great Red Spot or the icy plumes of Enceladus. The future of space exploration is not merely about reaching distant planets and stars. It is about expanding our knowledge, challenging our assumptions, and inspiring future generations to dream big. It is about leveraging the power of technology, not to replace human ingenuity, but to augment it, to enable us to see further, reach higher, and explore deeper than ever before. In the words of the immortal Carl Sagan, somewhere, something incredible is waiting to be known. With the combined forces of human imagination and artificial intelligence, we are poised to embark on a journey of discovery that will redefine our place in the cosmos and illuminate the path to a brighter future.